Welcome to clickmyproject.com. Let we discuss about the process edge-based forward vehicle detection method for complex scenes. Let me see the abstract of the process. The video-based vehicle detection method is capable of the continual operations under various environmental and illumination conditions. The identification of the features that adapt to various conditions were crucial. In this paper, we propose a robust vehicle detection method for identifying the vehicles in the videos based on the detection of horizontal coefficients based on Sobel filter to achieve the low complexities in the overall execution of the process. Based on the orientation of the gradient features of a vehicles that can be extracted accurately, the symmetrical features were critical features and a histogram of oriented gradients was employed to reduce the detection error rate. It is more advanced system and can be used to be suitable for the integration with advanced driver resistance systems and to show the forward vehicle horizontal and vertical conditions easily, such that the cases for the intensity to illumination of situation is tunnel, rainy, sunny, freeway for this timing situations. The detection of the vehicles based on the process has major applications in the development of automated surveillance systems. The object-based segmentation method that locates and identifies the input video objects in the video is proposed. The object approaches were robust to illumination variations. The proposed vehicles detection system uses the gradients and the selected ROI for the identification of the vehicle. The input video is initially converted into frames and the frames were then pre-processed using median filter. The edge regions were detected from the pre-processed frames using Sobel operator. The detected edge pixels were then used for the calculation of the gradient information. The image pixels present with the detected region of interest were chosen. The region of interest is selected manually by eliminating the road region in the frame. The pixel similarities between the region of interest and the detected edges gives the gradient informations of the frames. The obtained gradient informations has a combination of the detected object and other regions in the images. The gradient information removes the regions other than the road in the video frames. The obtained gradient regions were then filtered using morphological operations. Then, by measuring the area of the objects in the overall frames, the remaining regions in the images were removed. The detected objects were marked in order to identify them separately. The performances of the process is measured by measuring the accuracy and error rate of the detected objects in each frame. The accuracy and error rate measured shows that the proposed method is capable of the identification of vehicles in the videos in an effective manner. The overall accuracy of the processes ranges from 85 to 87%. Let me see the flow of the process. The input video is selected. After that, the videos were converted into frames. The frames were then pre-processed with the help of filters in order to make the overall intensities in the images to a particular level. After that, the region of interest were selected from the frames. The selection of the region of interest gives us the locations where the vehicles were presented in the overall video. The selected region of interest the region of interest is applied to all the frames in the input video. The process we have done is implemented for the videos obtained from the static cameras, and hence the similar background will be there for all the video sequences. The video frames were then extracted. After that, the edge detection methodologies is applied to the original video frames. The detected edge regions and the extracted region of interest regions were compared, and based on that, if they are matched, the regions were selected, or else the regions were used for the next process. The next process is the calculation of the gradient information from the images. The calculation of the gradient information normalizes the overall intensities of the images and produces the object's locations in an accurate manner. The identification of the objects in the videos is based on this process. After that, the HOG features were extracted from the images. The extracted HOG regions helps us for the identification and the selection of the regions in the images. After that, the small areas in the images were eliminated by morphological operations. After the detection of the small areas, we detect the vehicles in the overall images. As we can see, the videos is first selected and the vehicles in the videos were detected as a process. Finally, the performances of the processes were measured in terms of accuracy, sensitivity and specificity of the overall processes, and also we measure the true positive value, true negative value, all of them also, and hence we have detected the vehicles in the images, which is based on the thresholding operation and the ROI selection processes. So for this processes we have used the videos taken from the static cameras only. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. The process will get started. First select any one of the videos which is presented. So here we have given one video, so select the video. After the selection of the video, the videos were read and the frame conversion process starts. So initially the videos were read and they were displayed. So this is the displaying process for the videos. So for that, in play the default MATLAB functions were used. After the video has been displayed, the frame conversion process starts immediately. The frame conversion process refers to the separation of the video frames based on the frame height and the width in the videos. Then after that, as we can see, the pre-processing step is employed. So the videos were pre-processed, and after pre-processing the videos were displayed. After pre-processing step, we move on to the edge detection ROI mask regions. So this is the mask obtained for the input images, and this mask is applied to all the images in the all the video frames in the dataset, so that the other regions, lanes, etc. were presented in the videos were removed. So as we can see, the other regions were eliminated and only the objects within the locations were selected. So this process goes on. After the selection of the region of interest, the edge regions were detected in the videos, which is done based on the edge detection methodologies. Sobel edge detection is used in these processes. So as we can see, the images, the edge regions were detected, and the process goes on for all the frames in the videos. So after the detection of the edges, the process continues to the gradient calculations. So now as we can see, while comparing the detected edge regions and the region of interested selections, the pixels were selected, the pixels within the region of interest were extracted. So this is the gradient calculation of the overall processes. After that, the dilution processes and the removal of the other objects were done. So as we can see, while dilating, the required obtained objects were extracted very boldly. After that, the overall regions of the sizes were calculated, and based on that, the other regions were subtracted from the regions. So the overall vehicles moving objects in the frames were estimated with the help of this processes. As we can see, the objects, the all the vehicles presented in the video frames were extracted. After the completion of the process, the tracking process will start, and the overall edges were detected, and based on that, the tracking is employed. So as we can see, the each vehicles in the objects were tracked by identifying the starting position and the height and width of the overall extracted objects. So when comes to bigger objects, the objects were detected as a whole, and after that they were detected separately, and based on that, the process is done. So here each cars were tracked separately, were identified separately. Similar calculation of tracking. So here, as we can see, this is the overall accuracy rate that we have obtained, and this is the overall error rate that we have obtained, the sensitivity values, specificity values, and after that, true positive value, false positive value, false negative value, and true negative value. They were all calculated, and based on that, the overall performance of the process is obtained. This and region of interest selections. Thank you.